Here we are back where we left off talking about compound interest. We were saying about compound interest is determined by this formula. S sub t is the amount of total amount of your investment after t years. Okay, with a given principal of p for a rate of r. So S sub t is equal to p times 1 plus r to the power t. Okay, so now we're going to address taking a um, more frequent compounding period. So let's take a look at it. Okay. So if you want to earn more, you can invest with a higher compounding rate. So let's entertain this idea. If the interest is compounded quarterly, then your interest is determined 4 times a year. So how would that influence this formula? So here's what we're looking at. Okay. So the previous formula, as we saw up here, principal is the same. Okay. The rate is the same. However, the rate is now going to be distributed 4 times a year. So the compounding period is not t, but 4 times t for 4 times a year. And that being the case, your rate, you're not going to get that full rate. That rate's going to be chopped up in quarters as well. So here's the impact on that. So it's S of t equals p times 1 plus the rate divided by 4 to the power 4t. So we're assuming we're going back to this $1,000 at 5%, I guess. So here it is, the $1,000 at 5%, which by simple interest formula I think gave us 1,150, is now up to 1,160.75. That's with a compounding period of 4 times a year. So generally speaking, if we can now assume that we can say, well, what if we wanted to go monthly, then that would be n would be 12 times a year. So up here in this previous formula where we have 4, we would replace it with 12. So if you say 12, why not go daily at 365? So and if you're going to say go daily, why not go hourly, 365 times 24, and so on and so forth. So here's the new formula that we're going to use is the return S sub t is p times 1 plus the rate divided by n, where n is the number of compounding periods per year. Quarterly, n would be 4. Okay. Daily, n would be 365. So let's take a look at a few things. What rate must you invest to double your investment in 8 years in an account which compounds interest at 12 times per year? So here's a bunch of things. Okay. Look, we have to incorporate the formula. Okay, which we say is right here. Now let's take a look at what we have. We don't have our principal. Yet we don't need our principal because we want to double. So S sub t is going to be 2p and p is going to cancel out. Okay. We don't have our rate because that's what we're after. So these keep appearing. We do know the compounding period is 12 times per year, and we do know we're going to let it sit for 8 years. So here we're filling in that which we have. Okay. Here's our here's our formula. Again, we want to double our investment, so S sub t is 2p. Where rate is what we're after. Compounding is 12 times per year for 8 years. So that's what we get. Okay, our rate is the unknown. So here's our equation. Again, we're after r. Now, how do we solve this equation? Well, okay. Some might say, well, why don't you take the 96 root of 2? Well, I guess we could take 96 root of both sides. Okay, obviously we're going to need calculators for this. Or we can apply the log, take the log of both sides. Okay, so let's see what happens. Okay, take the log of both sides, we get the log of 2 equals the log of this quantity, but then we invoke the power rule, 96 ln of 1 plus the rate over 12. Okay, again, we've got to solve for the rate, so we're coming down to this. We're going to divide both sides by 96, okay? But now, so log 2 divided by 96 is this. So now we have this issue where we have the log of something, and that is where our variable is contained. So we're just going to go exponential. So we're going to raise both to the power, both sides to the power. We're going to raise each to a power of e. So we're coming here. We're going to convert this out of the log form into exponential form. So here we go. We got 1 plus r over 12 is equal to e to that power 0.0722. So we get a decimal value of that. Come back, sorry. Okay, decimal value of that. All right, then we're going to take 1 from it, then we're going to multiply by 12, and we find we get a rate of 877. Okay, rather 87. So here we go. You would benefit by trying that one on your own. Invariably, obviously, we're going to need a calculator. We're actually going to build a program for this. We'll show you that in another video. Okay, but so that's the rate that you must invest to satisfy this. If you can, if no one ever offer you that rate, if you can, go ahead and get it. And certainly, no one's going to offer it to you for 8 years, but that's the ideal situation. Okay, so let's look at this now. Okay. Here's the thing. We're looking at this. We're saying take that $1,000 that we invested. Okay. Our first time around, we said, well, if we invest it annually, and that is compounded annually, we get 1157. We showed you the formula that we used previously on the previous slide here. And here's our formula. Here's going to be our start formula. S equals P 1 plus R to the power N to the NT. So you want to work with this formula, okay? And we're going to, all things are going to be the same except for N, the compounding period. So we're going to look at that using that formula with compounding periods of, as shown in the table there. The principal is $1,000. The rate is 5%, and the time is 3 years. So here's what we get, okay? We figured these out. The annually that we figured out in the first slide, that was 1157. Quarterly, we figured 1160. Weekly, that N is 52, of course. We step it up a little bit. Daily, where N is 365, well, if you want to be technical, 365.25, counting a leap year, I guess. 1161.82, a little bit better, 7 cents better. Hourly, once hourly, N is 365.25 times 24. Minutely, oh my God, come on, N is equal to 365 times 24 times 60. And you can see it doesn't really change a whole much, though there is change beyond the second decimal place, but okay, it's dollars and cents anyway we're dealing with. So there is an all-inclusive formula. It's the compounded continuously, which would be not by the week, not by the day, not by the hour, not by the second, but every millisecond, if you will. That formula is this equation. S equals P E to the power RT, where E is our good friend, the number E, okay? So using that formula, that's an all-inclusive formula. So if ever you say compounded continuously, that's what we're going to collapse to, that formula. And if it says compounded hourly or daily, you might as well just revert to this formula, because as you can see, the impact is not going to be seen in dollars and cents. So there it is. Okay, S equals PE to the RT. It returns us that same quantity. Okay, that's the best compounding formula. That's the compounding formula that's going to give you your best return on the dollar. Okay, so that's what we're going to work with that formula. We're going to have some worksheets on that, and you're going to execute your program with that, and we'll talk about annuities on another slide. Okay, so there you have.